From reading the stars to running algorithms, humanity has always been on this quest to predict the future. So today, we're going to explore that ancient ambition and see how it completely shaped the world we live in.
You know, there's this great quote from the physicist Niels Bohr. Prediction is very difficult, especially if it's about the future. And that's the beautiful irony, isn't it? We are just obsessed with solving a puzzle that seems, well, fundamentally unsolvable.
So how in the world did we get from staring at the stars to running these incredibly complex algorithms? Well, that is the exact journey we are diving into today.
All right, let's kick things off thousands of years ago, a time when predicting the future wasn't just some fun curiosity. No, it was a matter of life and death.
Think about it. All across the globe, early civilizations were coming up with these really sophisticated ways to deal with uncertainty. In Egypt, you had the rising of the star Sirius, which was basically a cosmic alarm bell that the life-giving Nile flood was on its way. Then you've got China, where diviners were making short-term weather forecasts, and this is the really important part, they were actually recording the outcomes to see if they got it right. From Babylonia to the Mayan Empire, people were systematically observing the world around them, just desperate to find patterns. And this right here shows you just how advanced this all became. This is the Dresden Codex. It's a Mayan document, and it contains these unbelievably precise tables that track the 584-day cycle of the planet Venus. See, the Maya believed Venus was a super powerful omen for war, so they used these predictable celestial cycles to figure out the absolute best times for major events, like starting a battle. And this is a perfect example of humanity's first huge leap of faith, really. It was this slow shift from pure divination, trying to figure out what the gods were thinking, to systematic observation. It's the difference between seeing a message in a crack on a bone and actually measuring the height of a river. One is asking, the other is measuring.
Okay, so let's move on, because this is where things get really interesting. We're leaving behind the age of omens and jumping into the scientific era, where the hunt for patterns becomes way more rigorous and mathematical.
So in the late 19th century, the whole game changes. The focus wasn't just on making these one-off predictions anymore. Instead, scientists and economists started asking a much deeper question. Are there repeatable, mathematical cycles hidden in all the data of the world?
So you have this economist, William Stanley Jevons, back in 1878, and he's one of the first people to really tackle this. He noticed that economic crises seem to pop up every 10 years or so, and he's searching for something, anything, with a similar cycle, and he lands on sunspots. His theory was that sunspots affected the weather, which affected harvests, which in turn drove the whole economy.
And here's the thing. He was totally wrong about the sunspots. The correlation just wasn't there. But, and this is a huge but, his approach was the real game changer. He was one of the first to take a bunch of long-term data, actually hunt for a pattern, and then build a testable, causal model to try and predict the future. It was a brand new way of thinking. And this whole search for external causes like sunspots, well, it eventually led to the most profound, most mind-bending leap of all. The idea that sometimes you don't even need an external cause. The key to the future might be hiding in the past itself.
Okay, so fast forward to 1927. A statistician named G.U. Newell is looking at that exact same sunspot data, and he asks this radical question that just flips everything on its head. What if the key to the future isn't some external cause at all, but in the data itself?
His idea was actually pretty simple. He thought, well, maybe today's value is just
a combination of its value from yesterday and maybe a little piece of its value from the day before that. No external causes needed. Just its own history talking to itself.
And bam, that is the core idea of autoregression. Auto means self, and regression is just a fancy word for predicting a value. So it's self-predicting. It's this incredibly powerful insight that a time series often contains the seeds of its own future. And this became a foundational concept in, well, all of modern forecasting.
Now get this, at pretty much the exact same time, another massive breakthrough was happening. And it came from the most unlikely place you could possibly imagine, Russian poetry. A mathematician named Andrei Markov was analyzing the sequence of vowels and consonants in Alexander Pushkin's famous poem, Eugene Onegin.
And what Markov discovered was profound. It's now called the Markov property. He found that the probability of the next letter being a vowel or consonant depended only on the current letter. The whole history of the poem before that point, totally irrelevant. was as if the process had amnesia. It was memoryless.
Let's put it this way. Imagine you're a really simple weather forecaster using a Markov model. All you need to know is that it's sunny today to predict, say, a 70% chance of sun tomorrow. The model doesn't care that it's been a monsoon for the past week. Nope, that's all irrelevant history. The only thing that matters is the state you're in right now.
So you have these two powerhouse ideas, right? Autoregression, where the past predicts the future, and state dependence, or the Markov property, where only the present matters. These two concepts became the bedrock for pretty much all the sophisticated forecasting models we rely on today.
You know, when we look back, it's like we've been climbing this ladder of abstraction. We went from reading the world for signs, to searching for the math behind those signs, and finally to this incredible insight that the past itself can actually contain the formula for the future. It's kind of incredible when you stop and think about it. That same ancient, fundamental human need to manage uncertainty, to know if the harvest will be good, to know if a flood is coming, that is the very same drive that today powers the complex AI algorithms running our entire modern world, from stock prices to supply chains.
And that leaves us with one last big thought. We've come so far, from reading omens and bones to building these incredibly complex models. But if we finally reach the limits of prediction, are there still things out there that are just forever unpredictable? Or is this ancient human quest just getting warmed up?